So as the name shows, uh, binary means two value 0 or 1, but here we should not say like a 0 or 1. We have to focus on the binary target, right? It means the target should be binary. Example, so suppose you want to predict or you want to suppose identify the value which has a two classes, two category. That is called the binary. Example, you can say same example, very good example. The category like a gender has can be the male and female. So suppose we have a two category here. In that case, it can be the target value. So you want to identify the responses belongs to which category, right? So it can be the possible as well as. So please have a look on this theory. Dependent variable must be categorical. Sometimes we can say dictonomous, right? Dictomous, the same like a category. Obviously, it will be the nominal. Dependent variable can be the target variable. Independent variables must be metric, right? Scale or continuous. Okay. Same like a multiple regression. It is like a multiple regression, but actually it is not a multiple regression. Okay, so it give us the probability of occurrence of the target. So practically it is not a real classification. It is not a real prediction, but here we have to find out the probability. Example, uh, what is the probability to join our class? Right, it depends, suppose 60%, 90% or 95%. Okay, it can be the probability, right? So this is like a probability theory, depends upon the probability theory. So we have to find the probability actually, right? Not the real identification. Linear regression and the regression previously we studied, which was confirmed the predicted value, but here we find the probability value, not the predicted value actual, right? Now the rules. The first rule is two variables should be measured at the continuous level, right? Okay, so continuous level can be example. It can be the numeric value metric case, right? Both variables should be like a continuous level. Obviously, one variable should be the categorical, and others variable we have no problem. It can be the continuous, and it can be in the interval like a ratio scale. Okay, like agree, disagree, you know very well it is important, like these are the scales. And assumptions too is the linear relationship between the two variables. There should be at least some relationship between the two variables, right? If you remember last time I show you the linear references like that. Can you see here? So this is good. Two left two graph are good. This is not okay. Okay, so curve should be like that, and scatter plot you can easily use to check it. Okay, so I think we know this rule previously. Next rule, there should be a no significant outliers. You are also familiar with it. And the next rule is independence of observations, and dependent variable should be mutually exclusive and exhaustive category. Yes, it is again right. Independence observations mean to say independence. The result should be independence. Last we also checked it. And dependent variable should be mutually exclusive. Example, dependent variable example is gender here, like a male or female. They should be totally you know different, right? So they should be mutually exclusive. If gender is participated, it means to say female will be not participated. If female is there, then gender should not. That's like a mutual exclusive. Okay, so we are confirmed that these are the data. Please have some mathematically term here. Please try to again, it is comes under again the calculations. So just see, uh, in a multiple regression, you remember we used that equation previously where y is a target, b1 is like a constant variable, or like in intercept here, and these are the we remember, do you remember we calculated some coefficients? This is the value, and these were our independent variables x1, x2, x3, right? So this is the residual differences. So this was the equation of the multiple regression, if you remember. We will use the same here, but the difference is here only and only in the multiple regression there were only the n number of a independents, like a predictor. These are the, and target value dependent variables was the metric, right? But here this time y will be not a metric or a scale, y will be binary value. So obviously y should be nominal or categorical. Is it clear? I think this is a difference between the logistic regression and multiple regression. The rest of the equation should be same. So logistic regression analysis, we will find the probability of the occurrence. I told you probability. So this is the function probability of the y, mean to say how much probability to be for a that class. So this is equation 1 by 1 plus e raised to power minus like that, minus b0 like that. This is equations. If you will use if you will try to mathematically, you will take that then value, then 1 by e raised to power, it can be converted here. So now again the next equation can be e plus e raised to power plus this one. So you understand. So this is the basically the theory over here, calculation. I took this equations from internet, I put it here. So what we say basically e logit. Logit is basically the probability. We should say logit e square. So the whole equation should call the upper e the logit, and the below 1 plus e square logit. So this is a basically logit. So this we call the logit here. That's why the name is logistic regression, right? So we also say the odds. Probability also called the sometime odds. So we can also write here odds. What will be the odds? Odds mean to say probability. Odds. We have to calculate the odds, and e logit divided by odds, right? So what will be the equations? Odds by divided by 1 plus odds. So you can write directly these equations, but generally you can write that equation. So final equation can be like that: odds divided by plus 1 plus odds. So this is a mathematically term, and how we can calculate the odds. So SPSS need to be calculate the logit value, and odds you can easily do it. So basically this is the mathematically calculation based for the logistic regression. So here the case study which we will do practices. Uh, a marketer wanted to investigate the factor related to the loyalty of the buyer in shopping mall. This study includes the brand, income, and shopping. These are the some data, number of time visited in a year of a buyer. Marketer conducted an interview, like a survey or research for 60 buyers, right? Who visited shopping mall both for loyalty and with the non-loyalty, right? So they want to predict whether the buyers are loyal or not loyal, mean to say the regular customer or not. Likewise, I think. So please have a look. We have the data set here, and please try to upload the data set in a SPSS like it. So our task is to be to explore the probability of the loyal and the non-loyal customers. So please have a look. You will see here. So the coding is already done, I think, in it. Please have a look. This is a loyalty. Again, see, there is only two category, 0 and 1. 0 mean to say not loyal, 1 mean to say loyal customer, right? This is the type of a no, categorical, right? And brand, income, and shopping, again, it is here. You know, this is the scale or a continuous value. Okay, so this variables already calculated, I think, so it is not important for. So we will remove it. Okay, so we have no need it. So this is the actual data we have right now. Now the time for the application, right? We try to apply. First of all, explore a significance of an independent variable to categorize the target variable. Very good idea. because please remember, we use a independent t-test. If you remember, I think we have a independent t-test, right? So please think in practically how we can categorize two things. So obviously there should be some difference. If there will be a difference, then the things are different. Example, male and female can be different. Loyal customer or non-loyal customer can be only different then if we have a significant p-value. So already I use a significant sample t-test, right? So I will not use now. Just I previously used and I put it here, the result directly. And you know very well how to use a how to apply a independent t-test. First, I should check everything, right? So I'm not focusing on the assumptions or rule, just I applied because if there is a difference, significant p-value, then there should be difference. Okay, so please have a look. All the variables I found is significant almost here. Please think. One more thing, when I applied here, shopping variable, please have a look. Shopping variable is have a value little bit bigger, the p-value. So it is like a not as significant here. So by this result, it seems that the brand and income are ready to classify, or we can find the probability actually with the brand and income. But don't worry, I used we can use all variable together. But suggestion is to be use only that variable whose p-value is less than 0.05. So we can pre-sure that it can be very good idea to apply in our model, right? So please try to apply that one and see the p-value only, nothing to do other value. Okay, obviously t-test has some rules, normality is there, and equal variance, everything is there, you know very well. So obviously everything is there. So you also can check equal variance. So homogeneity of equal variance is already there here. So we know very well independent t-test. Okay. Okay. Now we apply the logistic regression, which is important. Okay. So let's see everything in here analysis part. So classify, no, we will not do the classify. We have to go for the regression. Can you see here the regression? Linear we finished last time, and no partially square, a binary logistic regression. Please find this one, click on it, right? So what will be my target variable? Loyalty. Okay, and brand income I can use first two, but right now I am putting in the covariates like exploratory variables, right? So please have a look at the first step. We will pick up the binary, we will select a binary regression. Second step, we have to fix the variable or data in our target or independent covariates like independence here. And the third step, what we can do here, we have some options like here, example categorical. So we have no categorical already we set, so it is not important, I think. So save, please see, you can see save a predicted value here, and unstandardized residual. You can also see, you know, the value of a residual. Do you remember the predicted value and the actual value difference? So this is the residual unstandardized. Here you can also use, and if you want to see, you can also calculate the logit value and group membership here. Okay, so it is okay. So here one more thing, group membership and probability, mostly we use a probability and group membership. So unstandardized, this is the basically difference. You can use, it is your choice, right? So next is the plots options here. You can also use some classification plots if you want. So here iteration history you can also see, which is important, and confidence interval like in 95% you can use it, and rest of the things are okay. So we will this is the by default value, probability of the stepwise. Why stepwise? Because if we have a, right now we have three variables, in the real life we can have a thousands of a variable. So this is the like a when some variables will be significant, some variable will be not significant. So depend upon this idea when it will be enter in the model, when it will be removal. Like a 10% value, so it should be removed. If it is a p values like that, then it is a good idea. So this is basically a cutoff value. So maximum iteration the model will use, you can put 100, 200, or every time it will do. So basically this is a bar default, we will not use it. Maximum iteration the same one. So is it okay? I think. So this is one what I think nothing to do. Style is not. It is important. So next, if you have some other target variable and other thing, you can go on the next. Otherwise, no. Right now we have nothing to do. So click on the OK. In the meanwhile, it will give us some output. Let's see. So I think we configured our logistic regression model application in the tool. Now, please have a look output. So I think my output should be here. Yes, I think it is here. Please check it. So have a look here. Nothing is there. When you will click here, logistic regression is here, right? So now block 0 and block 1. Block 0 is a base model, right? Which is like which is basically need to be compared, and block 1 is actual model. So we have to look at that one. So I will take the result from this area, right? Block 1. So this is block 0 is a it's a base model, right? So here please have a look. I think I use logistic regression here. So this is like a case summary. It is very basic. What are the data? 60 observations are there. I think 60 participants, buyers are there. Maybe customers are there. And dependent variables here, you will also see the encoding. Non-loyal were 0 and loyal were I think 1. It is the again a category. It is not. So block, this is the base model here. So I will tell you here the two likelihood error term, it should be low, right? So basically it is likelihood term is just a sum of same as a residual. If you remember in a residual in the multiple linear regression, like a difference between actual or that one. So here we have also a minus 2 log likelihood, right? It is like a residual here. Okay, so because block zero is a base model, so we are assuming in the base model 80, the value is calculated is 83. So practically this error term should be low. Okay, so this is a low likelihood. The value should be of this very low in our new model. So here you can see uh, okay, so let's see what will be the next one here. So I will show you here. This is a uh, value, and this is a step 0. Okay, so these are the some coefficient constant. It is showing again like a significant. So it means to say the model can be okay. All right. So next is to discuss here, I think the iteration history. Okay, iteration history, I would go for here. So I copy from here, and please have a look. We have to say the iteration. There were I think 20 iteration, but at a 7 iterations, the task was finished. So right. So we have a value over here. So please see, I told you this value. This is the actual value which our model is there. I told you in the base model, the value we found 83. This should be because difference should be very less for a target variable or sorry, a predictor value and the real value. So here is 83. I told you it should be minimum as minimum. So in what case we can see it is a minimum. Iteration history is here. So see please, this is actually our real model here, block 1. I told you. So starting from the first iteration, then 40, and then 33, and it is reducing, right? 31. It means to say the difference between the target value and sorry, predicted value and the real value in a data set is very difference is low. So up to last seventh step, it is 31. So after that, there is no possibility, right? So these are the basically idea to use it. And correspondingly here, uh, I wrote here the null model. In the null model, mean to say the base model, we had 83 likelihood value, right? So what we can do here, so in the real model we have that value, and right now we have 31.3. Please try to minus it, right? So I found a 51.8. This is the actual difference. So please see the 51.8 is a very big difference. It means in the base model, uh, this is the base model. So we can compare our models, right? So this is a very big difference. It means to say our model is likely good. If the value is like a 2, 3, or 4, so it means to say model is not good. So there should be 50% difference here, 51 value. So I think it is good somewhere. Huge reduction seems to be base model to the real model. So this is our real model, this is the base model, right? So this is the basically idea to use the and also the coefficient should be significant here. So please have a look. We have a coefficient value over here. So these are the value which you can put in the equations, right? So this is the overall coefficient, but for individual, the variable coefficient we have that. So coefficient are the only numbers, right? So again, these are the low here. So you have to put these coefficient in that one. Okay, I think it is clear now. Next is the there is a test, omnibus test of model coefficient. On which behalf we should say these coefficients are okay, mean to say the significant. Should we use this coefficient or not? Right? So there is a inbuilt test, omnibus test of a model for coefficient. Right? Previously, you saw in a multiple regression, we also tested the coefficient with the t-test, if you remember. So it is just like a t-test, but some other calculations are there. So omnibus test used for a check the coefficients, these numbers are valid or not, which is important. So please see, I found it is less than 0.05. Okay, so we can say, please have a look. We should say 0.05 mean to say 95% sure, but model is saying 0.01 mean to say 99%. Obviously, so obviously SPSS gives now this version gives us a 0.091. So the old versions by default give us a value 0.05, right? So because we are using a very latest new version of SPSS, in that case, it is that one. So practically it is a okay. So chi-square value is also good. Chi-square is a test. Maybe one day I will speak on the chi-square, but please have a look now. Chi-square is very most important for association, for finding a link. So this value should be always high. Now I can see there is a 51. In general, it can be 100, 200 something. So chi-square value. So we will talk chi-square later on in my one of topic, maybe last topic I will speak, but chi-square is important. So chi-square based on this value, it is important. So just we have to look on that value. So I should say the real model is coefficients are perfect and use. Now, so we saw the omnibus test is there, and now the important is the model summary. Model summary is important here, which we have to discuss in our result. I took that model summary here. So I put the model summary here, right? Please have a look. Because this is our real model, which has been calculated, but we have to compare this model with the base model or null model. Please have a look. The null model was that one. What was the likelihood residual 83? So let's see what is now 31. Do you understand? So this is the 50%. 50 difference is very huge difference, right? So this is the basically model. We need that one, right? I circled here the two most important statistics here. So basically, these are the pseudo value, right? Pseudo R square value. This is basically like a correlation type of value, but when we scale the correlation R value, R square, then it is called the explained variance. We, I think, checked in the multiple linear regression, but here two different techniques is using here. There is first is a Cox and Shell R and Negliker R. So two metric are also there which can help us to check out the dependent predictor or explained variable have how much capacity, how much percentage of explaining power, right? So here I found around a 58%. Please have a look, 57.57. I should say uh, income and the another variable. Let's see. I think here income, brand, and shopping. These three value can easily explain or categorize the loyalty target variable, right? Brand, income, and shopping. Have a look, 58% by this test and 77% by this metric. So basically, these are the uh, methods which can help us to explain the basically independent variables to categorize the target variable. So obviously, the value should be 0 to 1. Always remember this value should be 0 to 1, right? So I can see we are here very near this is showing near to 1. This is good one. So you can put in your result one metric or second two metric, so it is your choice, right? So this is basically the idea to check the model is okay or not. Okay, so now this was the basically model. Next is the classification table. We also found the classification table. You should also use that table in your results. So please have a look. I put it here, the classification table. So you have to use that one. This is the basically predicted area, vertical, and this is a actual observed, mean to say the data set. So we saw the some residual, so difference between that one. So please have a look loyalty. So I can see if you want to see non-loyalty customer here. So 27s are accurately classified because we have a 60 observations. Okay, in a 60, 27s are perfectly went into the non-loyalty category, and three were misclassification. Okay, similarly, for loyalty customer, you will see 25 were accurately identified or classified, right? It means to say probability we can easily do it. Okay, and five were misclassification. Okay, so this is the basically idea to use the classification table. And please go on the internet and you easily find that the some matrices, more matrices you can use the write the classification matrix. Okay, so our target is to be like a 86%. So please have a look for this percentage. It is calculated 90% for non-loyalty. For loyalty customer, it is 83%. So overall, we will say 86%. So I should say the model is correctly classified around 86% with accuracy, right? So I wrote here only 52 records correctly categorized and 8 were not identified honestly, right? So our task should be on to how we will see how we can calculate more than 52 exactly. It can be 55, it can be 60. If there is a 60, it means to say 100% your model is okay for apply in the real world, right? So please think this is the idea to use a classification table. Okay, so next is next one is the variables in the equations. Variables in the equations is important. I told you in the starting I use the t-test, and I told you the two variables are found are significant. But don't worry here, it will also calculate it for you. Okay, so please have a look. We have a again the brand, income, and shopping. Because I included three variables, I want to check what is the contribution actually of each variable, right? So please have a look in this model, in this slide. Please have a look. Income is, I found a very much significant, honestly. So income is very perfect variable, target explanator variable, right? So this independent variable income, if I will use the income variable in my model, then I can found a very good result, right? So brand value is again a non-significant, but important is to be here in this variable in equation. We have a something new test, that is a walled test. Please Google it later on. Wall test here. This one is, we have to see that value. right? So this value should be high basically. So it is around a 1 2 like a 12 here for income category. So it is used to uh, find out statistical significant for each independent variable. It is just like our t-test if you remember, right? Value should be significant here. So I put in this example only income I found, which is very good. Okay, now I told you I put again here some equations here. So our target is to be use that equations and find out the results. So find out the result mean to say the probability value we need to find out. So I want to make my own equations. In that case, I put here the logit here. In the last I write here, I think logit here, right? Logit by 1 plus like that. So how I can calculate the logit? So I can put all the, because now I have the result, I can put in my equation. So I can put very easily the constant value, right? 3 here. Can you see this is a constant here, right? Okay, and plus constant mean to say I can control the other variables, right? So now next is the brand. Obviously, I know very well income is very significant. I should include the income, but I included other variables as well as, because this all results 86% accuracy based on that three variables. So that's why I put it here. But I know very well only the income is very perfect predictor, right? So you have to put again the value coefficient value of a brand. So what is the coefficient value of a brand? 0.25 here. I put it here. Next, income 1.77. So you, this is the actually B value. This is the your coefficients. B is a coefficients here. And for shopping, this is a minus value I put. So this is the equation. Whatever the value you will calculate it here, it will be our logit value. You can take a calculator and the system will automatically do for us. Right. So let's go for our Excel data set file. Please have a look. There is a new variable because we selected the options. This is the predicted probability, right? And this is the target value. This is the outcome, right? This is the outcome, and this is the, and this loyalty was our target, if you remember, right? This one is, this was the target, and this is the our results. These two are actual result. Okay, so you see this is the probability value. I show you here in the, so by manually we can give an equation, and this is here. So I took the result from this table. I took a snap because I have no idea to take all the results. So just I took for your helping the snapshot like that. So here, please have a look. Remember what was zero? Actually, zero was a non-loyalty customer here, right? So for a loyalty customer, one is for loyal. There is a probability of this record, right? 63%. So 63% for this record, this buyer, there is a probability for having a right customer, for right loyal customer, right? The probability of one is 63%. Take another example. For this record, for probability for making a loyal customer is a 70%, right? Okay, so example, so there is a, this one is not good because there is no probability of this one. This maybe it can be misclassified. So the classify, these are the values which actually classified with the loyal customer here. These are the non-loyal and loyal customer. So based on that, we can easily, because the results in our hand, we can check it, right? So you have a long ideas. Please see, you can calculate here again, right? Please see, this is not loyal. This is, the model is saying this is not loyal. Okay, so this is not loyal, but please have a look. This is the model is saying it is a loyal. So in the, this is in the data set in actual, this is real. So it is match. Okay, just think. So again, not loyal and loyal. This is again a match, but please see this is 70%. So this is very good, right? So the difference you can see is residual here. This is a basically difference. This is the another variable, I think, another unstandardized residue, I think. So this is also here. So this is again like a difference. So we calculated previously, right? So this is the basically idea to apply the logistic regression. So here you can use the information in a variable equations to predict the probability of occurrence of the unit change in the independent variable when all other independent variables are keep constant, right? So this is the basically binary logistic regressions results. In the last, I have to write something for conclusion, right? How we should write our basic conclusion in the result final answer. 3 lines you need to do that. I wrote here the logistic regression model was statistically significant based on x3. So this is what is this x3? X3 was actually the chi-square value, right? So chi-square value I show you previously here. I think here 51, right? This value should be again high, but still this model is good, but we should improve it. If we have a more variable, if we have a more data, right now we have a 60 observations. In real, we can have a thousands of observations. 100,000 buyers can be there. Right now we have only 6 buyers. So please see, we have to write that. So how many, in model we consider only 3, predictor or explain variable: income and brand and shopping, right? That's why I put 3 here. And the value is the chi-square is 51. I take it here there, and the p-value we found significant here. So we can say the model explained 58% with the Nagelker scale. Okay, and also I think I should put the another 77%. I think you can also put. I think I forget to put that one here. You can also put here from another value from. I think it is in the model summary. So I took this value 57%, right? 58%. You can also put the 77%, but better. This is the Nagelker, so 77.2. It is good, right? Now it is good. So 77%, the model is explained. These variable are explaining very well based on this test, right? Okay, of the variance in the loyalty and correctly classified with the how much accuracy of the classification table? 86%. 86% here. I can write a 87, but we should write in the exact decimal point. 86.7% cases are correctly classified.